Hey guys, welcome to the next video on Docker tutorial for beginners. In the last few videos, we have seen the fundamentals of using Docker files, Docker images, and Docker containers. Now in this video, I want to give you a concrete example of using the Docker container. So I'm going to give you a real world example of how you can really use Docker containers and how these Docker containers are really useful in certain situations. So we are going to compile and run a C++ program inside a Docker container. Now you might say that compiling and building a C++ program on your host operating system is also easy, so why do we need a container? So consider a situation in which you have a C++ program and you want to compile a C++ program with different version of GCC, let's say. Now it's really hard to maintain different version of GCC on your Linux or Windows operating system, but using Docker containers it's really easy to use and compile your program in different GCC versions using Docker containers. Also, let's say you want to develop a C++ program which works on multiple operating system, or you want to compile your C++ program for a cross-platform application. So Docker containers are really useful for C++ cross-platform development with containers. With containers, you can choose a target with a platform that runs completely different operating system other than your host operating system or the system on which you are developing. So let's say you are just working on your Windows operating system, but you want to compile your C++ program on a Linux operating system or any special version of Linux operating system. You can do it easily with the Docker container. So let's start with our example. So as you can see on my Visual Studio Code, I have opened a Docker folder, and inside this Docker folder I have this directory D1 which we have created in the previous video. And now I'm going to create a new directory inside this Docker directory, and I'm going to name this directory as D2. And now I'm going to just go inside this D2 directory. So let's go inside this D2 directory, and here inside this D2 directory I'm going to create a new CPP file, let's say. So you can use touch on the terminal, or you can just click on new file here and then just create a new CPP file with the extension CPP. I'm going to name my file as main.cpp, and as soon as you create a CPP file inside your Visual Studio Code editor, it's going to give you the suggestion for the C++ extension. So I'm going to install this C++ extension. So now this C++ extension is installed, and this C++ extension is going to help me to work with the C++ file inside my Visual Studio Code editor. So what I'm going to do here is inside my main.cpp file, I'm going to just write a very simple program here which just prints hello Docker container. So normally what you will do on your host machine, if you have a G++ or GCC, you can compile your C++ program using G++, right? So you can see I have this main.cpp, so I can compile this program using G++ -o and then the executable file name which I want to create. Let's say I want to just give the name test to my file, and then my main.cpp file, right? So I'm going to just press enter, which is going to create this executable file. You can see here also I'm going to do ls here also, so you can see this executable file. And now you can just run this test executable file or binary file using this command // and the name of your binary file, and it's going to print hello Docker container. And I want to create a Docker container, and I want to compile my C++ program inside my Docker container, and I want to run my C++ program inside my Docker container. This is what I have done in my host machine, not inside my Docker container, right? So let me just clear the terminal, and inside my D2 directory where my C++ file is there, or my CPP file is there, I'm going to create a Docker file. So I'm going to just right click, and I'm going to just create this Docker file here, and then press enter, and I can remove this test binary file because I don't need it for my Docker container. Now if you don't know which base image you want to use, so for example, if you want to use GCC to compile your C++ program, you can go to Docker Hub and search for GCC here, and when you search for GCC, you will be able to find the official GCC image here. You can see Docker official image, or let's just press enter and see what result it gives. So you can see the official image is this one with this official image tag, and it has more than 10 million downloads. So I'm going to just click on this GCC link, and you can see when you just scroll down what are the tags you can use with GCC. Also, you can see how you can pull this GCC base image using Docker. So the name is really simple, GCC. So what we are going to do is we are going to just write from, and then our base image I'm going to use here is GCC. Now the version or the tag I want to use here is the latest, or you can choose the tags which are available here. So you can choose 10.2.0 or 10.2, or from all these tags which are available here. You can also go to tags section and see the more specific tags you want to use for your C++ program. So now once we have the base image, the next step is to copy our current folder which contains our CPP code into the Docker image under the file system where we want to copy this. So for copying our local files into the Docker image, we use this copy command, okay? And as you can see, it suggests us that we need to provide the source. So source in our case is dot, because we want to copy all the files from the current folder, and the destination will be the destination inside the file system of your Docker image. In our case, it's GCC. So in GCC base image file system, you will find this path which already exists there. So you can just write user/src, which is already there inside the file system of GCC base image. Okay, so as I said, this command is going to copy all the files which are there in your local directory to this directory inside your Docker image. Okay, now if you want to copy some specific file, then you can do this also. You can just write main.cpp, and then you can copy a specific file into the folder which should already exist inside your image which you are using, right? So for now, for simplicity, I would just want to copy all the files from the current directory to user/source/ the directory which we are going to create. So let's say we want to create this directory where we want to copy all the files, cpp test, let's say. So this path already exists in the file system, and this is the folder name which we want to create and copy our local files to this folder in the Docker image, right? Now we are going to define the work directory. So we can just use this work dir keyword to define the working directory in which you want to work now. Okay, so because we want to work inside this directory, because we are copying our C++ file inside this directory, we are going to set our work directory as this one. That means when you run any command, it's going to run inside this directory which you set as work directory. Now in the next step, I want to run the command which will compile the C++ program using this main.cpp. So now I can just give the g++ command, then -o as the flag, and let's say I want to name my binary as test, and the file name which I want to compile is main.cpp. So this run command is going to compile my C++ program inside my cpp test directory under user source folder, right? Now in the next step, I'm going to give the command using cmd, which will be the command which I want to run inside the container. So this is going to run the program output from the previous step into our container. So this works like this, as you have already seen in the last video also. So if you want to run your binary, you can just give / and the name of your binary, which is test, right? So this binary is going to be run using this cmd command inside our container. So that's it. That's how you can create this Docker file to compile your C++ program and run it. Now let's build our Docker file to create an image. For that, you can just give sudo docker, then your build command. So build and then the build context, and then you can provide -t to provide the name of your image. I'm going to name my image as cpp_test, for example, and then you can also give the tag to your image. Let's say I want to provide the tag 1 to my image. Okay, so this is going to create a Docker image using the Docker file. So you can see it has pulled the base image in the first step, then copied our files from the local directory to the directory which we have defined, and then it has set the work directory, and then in the next step it has compiled our C++ program, and in the last step we have set the test binary to run when we run our container. So now let's list out all the images. You can just give docker images command for that, and you will see that this repository is created about a minute ago, and this is the image ID for that image, right? So now we want to run our container using this image. So for that, we have seen in the last video, we can give sudo docker run command, and then I'm going to give the --rm flag, and this rm flag causes Docker to remove automatically the container if it already exists. So if the container which we are going to run already exists, then it's going to remove that container, and then it's going to rerun that container. So this command is handy when you want to just run only one container at a time. And then I'm going to give this it flag with hyphen, so it flag for running this container in the interactive mode, and then your image. So you can give this image name cpp test here, or image ID also you can give. So I'm going to give the image name, which is cpp_test with the tag. So tag we have provided is 1. Okay, so here, as I said, you can give the image ID or the repository name and the tag, and then when you run this Docker container, it's going to print hello Docker container. That means we ran the test binary inside our Docker container, right? Now, as I said, you can change this tag. Instead of latest, you can choose the version of GCC you want to use for compiling and running your C++ programs. So that's why this Docker and Docker containers will help you to just cross compile in cross platform applications. Now let's say you want to compile your C++ program using the clang compiler instead of GCC. Okay, so we want to compile our program using clang compiler instead of GCC. So let me clear this terminal and let me go one directory up here, and I'm going to create a new directory. So I'm going to just write mkdir d3, and inside this d3 directory, what I want to do is I want to just have the same cpp file. So I will just copy this cpp file into the d3 directory also, and then we are going to create a Docker file inside this d3 directory. So let's create this Docker file here. So now let's move to the Docker Hub website and let's search for clang if we have something related to clang compiler on Docker Hub or not. So I'm going to just write clang here, and as I remember, there is no official base image for clang on the Docker Hub. So what we can do, we can use the base images we already have on our system, and then we can install the clang compiler on that base image. So I'm going to just give this sudo docker images command, and from these images, let's say we will use this Ubuntu latest or Ubuntu 20.04 to compile our C++ program inside the Ubuntu base image using the clang compiler. Okay, so what I'm going to do is I'm going to just write this kind of Docker file. I'm going to explain you all the steps one by one. So we want the base image Ubuntu with the tag latest because we already have downloaded or pulled this image in the previous videos, so we don't need to pull it once again. Now in the next step, I'm running apt get y update and apt get install update to update apps on the base image. So that's what you do when you want to install any software on your Ubuntu operating system. So this command is going to update the apps on the base image. Now in the next step, using this apt get -y install clang command, we want to install clang on our base image, which is Ubuntu, right? The next step are relatively easier because we have seen these steps in the other Docker files also. So we want to copy all the files in the current directory into this directory inside our base image, and then we want to set the work dir, which is the same where we have copied our C++ files. And then to compile your C++ program using clang, you can just replace the GCC with clang++, and the rest of the command will look like same as you have seen in the case of GCC also. So you can see g++ -o test main.cpp, and here also you can give this command. The only thing I want to change here is the main.cpp, the file name here. Okay, because our binary name is test, we are going to just run this binary using this command. So this is going to run inside our container. Okay, in the D3 folder, I have created this Docker file to compile my C++ program using clang, and I'm going to run this now. So let me clear the terminal once again. So now let's build our Docker image using this Docker file. So for that, I need to go inside the D3 directory, and then I'm going to give the Docker build command with the context in the current directory, and then -t to give the name of my image. So let's say I want to give the name to my image as clang_cpp, and the version or the tag which I want to provide here is, let's say, 1.0.0. Okay, so let's build our image using this command. So now, as you can see, the build of this image is successful with the name clang_cpp and the tag 1.0.0. So let's run the container for this image using the docker run command. So I'm going to just provide sudo docker run. Oops, by mistake I pressed Ctrl+C, that's why it braked. So let me just give this command once again, and then give this image name with the tag 1.0.0. So we want to run our container using this image. So let's press enter now. and as expected we see hello Docker container. That means we successfully ran this binary file which is compiled using clang in our container, and the output is printed. Now let's say you want to change something in the output. So instead of let's say hello Docker container, I just want to print hello world here. Okay, so I will just save this program, and then I can just build it again, but this time I will build it with the different tag. So let's say I just did the minor change, so I will just change the tag as 1.0.1. so let's build this image, which is going to be built really fast. And now let's run this image using this docker run command, but don't forget to change the tag, because I have changed the tag for the image also to 1.0.1. so here also I'm going to change the tag for the image, and then press enter, which is going to run this program, and it prints hello world. So how simple is this? So this is how you can compile and run your C++ programs using Docker containers. So as I said, I just wanted to give you a real world example. Same thing you can do for your Java programs or any other programs which you want to run in different environments. So I hope you've enjoyed this video, and I will see you in the next video.